So page 133, number 8, we've got this pilot flying a stunt plane pulling out of a dive at a constant speed of 540 kilometers per hour. What's the minimum radius for the acceleration? Remember, this is going to be centripetal acceleration, is not to exceed 7g. Okay, so a couple things. This velocity, I don't like kilometers per hour. I want it into meters per second. So that looks like 150 meters per second. Also, this 7g, remember g is 9.8. So what they're saying is the acceleration shouldn't exceed 7 times 9.8. 7 times 9.8, 68.6 meters per second squared. Okay, so there's our numbers, really. When it talks about centripetal acceleration, let's squeeze it in over here. Acceleration is v squared over r. This is centripetal acceleration. We know AC, 68.6. We know v, 150, that's squared over r. If we rearrange that, we are going to get r is 327.988. So it's about 330 meters for the radius. And textbook says 3.3 times 10 to the 2 meters. Same answer, just in scientific notation. So this is part A. For part B, they ask what force is applied by the pilot, on the pilot by the plane seat at the lowest point. Okay, so if you can kind of imagine right here, here's the pilot. I'll kind of draw it lightly here. Here's the plane seat, something like that. I don't know if you can see that very well. The force is actually on the pilot. There's going to be a normal force, because remember, this pilot is sitting on the plane seat. There's also going to be some gravity pulling down. And out of those two forces, remember where the center of the circle is, the net force, the centripetal force, has to be towards the center of the circle. That means Fn has to be greater than Fg. So I don't know what that force is, but I know it's greater than Fg. Centripetal acceleration is towards the center of the circle. I want that to be my positive direction. Okay, so if I can kind of squeeze it out here, let's see if I can get it here. We know Fc is mv squared over r, just r, no squared. When I look at those forces, again, up is positive, so Fn minus Fg equals mv squared over r. I can bring Fg to the other side, plus Fg. And again, Fg is just mg, mass times 9.8. So we know Fn mv squared over r plus mg. When we go ahead and do this, we could have, I could have left this as just ma, by the way, because we know what our a is. Anyways, let's put our numbers back in. We figured out all these numbers. The mass of this pilot is 82 kilograms. V is 150. R, I'm going to use this unrounded, so R is 327.988. You can keep more decimals if you've got them. And we'll fill in mg. If we go ahead and figure these numbers out, let's see. We've got 5625.206. This one is 803.6. We can add those guys together. 6428.806. And then round that for sig digs. I think we're in 2 sig digs. 6.4 times 10 to the 3 newtons. It is up. Oftentimes they're just going to ask us the magnitude, but to be really good here, we could say this thing is a vector, is up.